Imagine looking up at the sky and seeing a perfect circle of clouds driving straight toward you. On September 6, 2017, Hurricane Irma made landfall on the tiny Caribbean island of Barbuda. With sustained winds of 295 kilometers per hour, Irma carried the combined force of dozens of ordinary hurricanes. The storm's full diameter stretched 660 kilometers, roughly the distance from Hanoi all the way south to Da Nang. This was the most powerful Atlantic hurricane ever recorded outside the Gulf of Mexico, and the story behind it carries warnings we have yet to fully understand. To understand why Irma became the monster it did, we have to start where every hurricane starts, at the surface of the sea. September marks the peak of Atlantic hurricane season, when tropical seas have been absorbing heat for 4 consecutive summer months. Sea surface temperatures in 2017 ran nearly 2 degrees Celsius above the historical average, enough fuel to push a storm far beyond ordinary predictions. On August 30th, Irma was named as a modest tropical depression, roughly 2,000 kilometers off the West African coast. Within 4 days, it intensified from a tropical storm to Category 5, the highest possible rating on the Saffir-Simpson scale. The Leeward Islands, whose people had weathered dozens of storms, had never faced anything remotely like what was coming. On Barbuda, more than 1,800 residents sheltered inside low concrete homes as the sky turned an eerie green on the night of September 5th. The storm's central pressure had dropped to 914 hectopascals, lower than almost anything ever recorded over the Atlantic. That night, on Barbuda, the sound of the wind changed from a whistle to a roar that had no end. At 5:47 in the morning UTC, the eye made direct landfall at the center of Barbuda with winds of 295 kilometers per hour. This was the first time in recorded history that a Category 5 hurricane had made a direct hit on Barbuda. Peak. 95% of every structure on the island of Barbuda was destroyed or severely damaged in under 4 hours. Irma's winds did not merely strip roofs, they scraped the topsoil and every leaf from the entire island. Consider what that means. An entire island stripped bare, no roofs, no trees, no clean water, no electricity. Barbuda had been continuously inhabited since 1652, more than 300 years without interruption. On September 9th, for the first time in over 300 years, not a single person remained living on Barbuda. Meanwhile, Irma did not pause. It drove westward at 25 kilometers per hour, aimed directly at Puerto Rico and the Virgin Islands. Over the U.S. Virgin Islands, the eye passed just tens of kilometers off the northern coast, enough to destroy 70% of all infrastructure on St. John. This was no longer a hurricane passing through the Caribbean. It was a destruction machine, nearly as wide as France itself, grinding through everything in its path. As it tracked north of Puerto Rico, Irma drove storm surge 6 meters high along the island's northern coastline. Electricity pylons, bridges, and thousands of rooftops along the northern coast were swept away like paper in under an hour. More than 1 million people in Puerto Rico lost power, a number almost unimaginable, until Hurricane Maria arrived 3 weeks later and erased what remained. NOAA later confirmed that Irma maintained Category 5 intensity for 37 consecutive hours, breaking every previous record. 37 hours, nearly 1.5 days of unbroken winds, powerful enough to destroy any standard building construction. Understand it this way: while you slept through a full night and woke the next morning, Irma was still at Category 5, unweakened, unstoppable. At that point, modern meteorological models had no accurate way to predict intensity being sustained at this level for this duration. On September 8th, Irma plowed along the northern coast of Cuba's Camagüey and Villa Clara provinces, with winds of 260 kilometers per hour. Along Cuba's coast, small fishing villages sitting at sea level watched storm surge taller than the second floor of an ordinary house roll inland. When Irma left Cuba and turned toward Florida, it was still a Category 4 storm, with winds of 225 kilometers per hour, strong enough to be the most powerful storm in history compared to almost any other hurricane. The Florida Keys are a chain of small islands connected by long bridges, sitting on average just 2 meters above sea level. 600,000 residents of the Florida Keys and Miami area received mandatory evacuation orders before Irma arrived, one of the largest evacuations in American history. 6,300,000 people left their homes across Florida, a migration larger than the entire population of Hanoi. On September 10th, at 9:10 in the morning local time, the eye made landfall at Cudjoe Key in the Florida Keys. At Cudjoe Key, storm surge reached 4.5 meters, nearly the height of a 2-story building, flooding the entire surface of the island. Mobile homes throughout the Keys, never designed to withstand winds above Category 3, simply ceased to exist. The 7-mile bridge, the Florida Keys' iconic 11-kilometer span, crossing shallow turquoise waters, survived structurally but remained unusable for weeks, buried under sand and debris. Picture it this way: every home, every shop, every street from Key Largo to Key West was in complete darkness and unreachable for more than 2 weeks. While the Keys were submerged, Irma pushed onto the Florida mainland with winds of 185 kilometers per hour, making its second Florida landfall at Marco Island at 3 in the afternoon. Naples, Fort Myers, and the entire southwest Florida coast received storm surge between 4 and 6 meters, higher than the roofline of most homes in those areas. In Fort Myers, home to Florida's largest concentration of mobile home communities, entire mobile home neighborhoods were completely leveled. This was not the story of a few weak structures being damaged. This was the story of entire communities being erased from the map in a matter of hours. As the eye pushed north up the Florida peninsula, the most powerful winds shifted to hit east of the center, devastating Naples before reaching the Tampa Bay region. Tampa Bay is Florida's second largest metro area with nearly 3 million residents, and the bay's geography makes it uniquely vulnerable to storm surge when winds arrive from the west. Tampa Bay had not taken a direct hurricane hit since 1921, a 100-year gap that left millions of residents with no memory of what a real storm could do. But Irma made a different choice. It tracked northeast through Florida's interior rather than driving straight into Tampa Bay, and that single shift changed everything. Instead of 6-meter surge flooding Tampa, the water level in the bay actually dropped while the storm was approaching, as offshore winds pushed water out of the bay before landfall. This is one of the most counterintuitive phenomena of tropical storms. Winds can pull water out of a bay before pushing it in, depending entirely on the track of the eye. By the morning of September 11th, Irma had weakened to Category 1 while crossing inland Georgia, bringing record flooding rains to the low-lying agricultural land. On September 12th, Irma officially dissipated over Tennessee, 13 days after being named over the Atlantic. 13 days, more than 3,000 kilometers from the Atlantic into the American interior, and the storm had left its mark on everything it touched. 134 people lost their lives directly to Irma across its entire path, from the Caribbean to the American Southeast. Think about that number again. 134 lives across a destruction corridor more than 3,000 kilometers long. A toll kept that low, largely by early warning systems and evacuation orders. Total economic damage reached $77.16 billion, making Irma one of the most costly storms in human history. $77 billion, equivalent to Vietnam's entire national budget for more than a year, swept away over 13 days. In the Florida Keys, 90% of all homes on the lower Keys were damaged or destroyed, with a quarter of them completely gone. On Barbuda, all 1,800 of the island's residents were forced to live temporarily on neighboring Antigua for months, because Barbuda had lost every condition necessary for habitation. That same week, while the world was watching Irma, Category 4 Hurricane Jose was forming directly behind Irma over the Atlantic, tracking along nearly the same path. 2017 became one of the costliest hurricane seasons in recorded history, with Irma, Harvey, and Maria forming a trio of disasters that permanently reshaped the American insurance industry. After Irma passed, NOAA scientists found the storm had significantly cooled the ocean surface along its track, dropping sea surface temperature by up to 3 degrees Celsius. That sounds positive, but that cooled water lasted only days before the sea warmed again, ready to fuel the next storm. The mangrove forests of the Florida Keys, the natural wave-dampening barrier that protects coastal land, were severely damaged across wide areas and would need 5 to 10 years to recover. Without mangroves, the coastline is exposed directly to wave action and surge from future storms, creating a compounding cycle of vulnerability that builds over time. On Barbuda, scientists recorded another unexpected consequence: the permanent alteration of the Codrington Lagoon ecosystem, home to one of the largest frigate bird colonies in the Caribbean. 5,000 frigate birds lost their entire nesting colony in a single night, an ecological loss scientists estimated would take 20 years to recover. Back in Florida, the rebuilding process exposed another problem. A significant portion of the destroyed homes in the Keys had been built before Florida's modern hurricane building code was enacted in 2002. Homes built to post-2002 standards largely survived, while older homes collapsed directly beside them on the same street. This was a lesson structural engineers had long known, but homeowners and developers often preferred not to hear, until Irma proved it house by house and empty slab by empty slab. After Irma, Florida expanded its requirements for impact-resistant windows and doors statewide. Not just in coastal areas, NOAA's hurricane forecasting systems also received significant upgrades after Irma, particularly the intensity prediction models that had been the weakest link in hurricane meteorology. In the U.S. Virgin Islands, Irma's destruction was so complete that the U.S. government was forced to acknowledge that the territory's infrastructure was outdated and entirely unsuited to a hurricane-prone region. At the same time, the international community looked at Barbuda with an unavoidable question: should this island even be rebuilt in the same place, in the same way, at all? This is a question that a growing number of low-lying islands across the Pacific, Indian Ocean, and Caribbean are being forced to confront as sea levels continue to rise. Irma was not the first hurricane to devastate Barbuda, and given current trends, it will not be the last. Scientists from Colorado State University and the National Hurricane Center analyzed Irma and concluded that warmer ocean temperatures played a direct role in pushing the storm beyond all conventional predictions. More specifically, the research team determined that with historically normal ocean temperatures, Irma might only have reached Category 3 or 4, rather than holding at Category 5 for 37 hours. That may sound like a modest difference on paper, but the real-world gap between Category 4 and Category 5 can be the difference between your home still standing or no longer existing. Today, Miami remains one of the world's most vulnerable cities to tropical storms, with more than 2.5 million residents living within potential flood zones. Tampa Bay, the city that narrowly escaped Irma's full fury in 2017, is still ranked as the most storm surge vulnerable metro area in the United States. Researchers estimate that a storm tracking just a few dozen kilometers differently from Irma could have driven 6 to 9 meter surge inside Tampa Bay, with potential damage exceeding $100 billion. Scientists call this latent risk, a major city that has never experienced catastrophe and therefore has not built sufficient defenses to survive one. The Netherlands, Japan, and Bangladesh each had to learn this lesson at the cost of tens of thousands of lives before building world-class flood defense systems. 6 years after Irma, the Florida Keys had still not fully recovered, with some areas of the lower Keys still showing empty foundation slabs and abandoned lots. On Barbuda, people slowly returned from 2018 onward, but slow recovery and disputes over land ownership deepened divisions within the small community. But one thing had changed on Barbuda that could not be reversed. A portion of residents had left permanently, taking with them the memory of an island that those who stayed were trying to recreate. What Irma exposed was not only the fragility of small islands and mobile homes, but the fragility of entire systems, from infrastructure to policy, from ecosystems to communities. Modern meteorology can predict a hurricane's track with remarkable accuracy 5 days out, but forecasting intensity remains the hardest problem in the field. Irma forced NOAA to invest hundreds of millions of dollars in new intensity forecasting models, including satellites monitoring ocean heat content in real time. Data from Irma also helped confirm that future storms are likely to reach higher intensities more rapidly, a phenomenon scientists call rapid intensification. Rapid intensification is the worst-case scenario for coastal cities because it can turn a Category 2 storm into a Category 5 in under 24 hours before evacuation orders can even be issued. Manila, Ho Chi Minh City, Dhaka, and Miami are all among the major cities scientists have identified as particularly vulnerable to rapid intensification storms in the coming decades. Ho Chi Minh City, Vietnam's largest city with more than 9 million residents, sits below sea level in many districts and is subsiding at 3 to 4 centimeters per year. Irma was a storm that science could see forming but could not prevent, and that is the clearest lesson its story teaches. The early warning systems worked superbly. Evacuation orders were issued in time, and those two things alone saved tens of thousands of lives in a storm that could easily have killed hundreds of thousands. But early warning only works when there is somewhere to go and someone who will listen. And neither of those things is obvious everywhere in the world. Barbuda, with 1,800 residents, could be fully evacuated in hours because the island is small and had one exit, a single ferry. Imagine the same scenario for a city like Manila or Ho Chi Minh City. Millions of people, hundreds of thousands of homes, with a storm just 24 hours away. This is why Irma, a storm that was predicted, tracked, and triggered one of the largest evacuations in American history, remains an unfinished lesson. Future storms will form over warmer seas, will intensify more rapidly, and will carry more moisture inland. Rising sea levels mean storm surge will push further inland, even from storms of identical intensity. And tens of millions of people continue moving into coastal zones every year, with full knowledge of these risks. Irma proved that early warning systems, when properly funded and trusted by the public, can save tens of thousands of lives, even against the most powerful storm ever recorded. It also proved that building standards are the line between your home existing or not existing after a storm passes. And it proved that natural ecosystems like mangroves and coral reefs are not ecological luxuries, but natural defense infrastructure that no budget can fully replace. Today, the sky above the Caribbean looks no different from September 2017. The sea is still warm, the winds still blow westward from Africa, and the conditions for storm formation are all still there. The only difference is the sea is now slightly warmer than in 2017 and measurably warmer than any decade of the previous century. Current climate models project that the proportion of storms reaching Category 4 and 5 intensity will increase in coming decades, Even as the total number of storms may decrease, that means in the future, when a storm forms, it is more likely to become another Irma, a storm unlike anything the current generation was taught to prepare for. Return to that image from the beginning, a perfect circle driving straight toward you. 37 hours at Category 5, $77 billion of damage, 300 years of island habitation interrupted, and all of it began from the warmth of a small patch of ocean off the West African coast. That perfect circle has passed, but the conditions that created it remain. And the question is no longer whether a storm like Irma will form again, but when. And this time, where it will drive straight toward